Units and measurements. Measurement: the comparison of any physical quantity with its same kind is called as measurement. Now to explain this, I have two boxes marked A and B and I want to compare. The first thing comes in your mind is the length. The length of these two boxes are different. Second thing is the breadth and the third thing is the height. So all the length, breadth and height is different for the two boxes marked A and B. And specifically if I want to describe, I would say the size or the volume of the two boxes are different. I can say the volume of A is less than B, or I can say the volume of B is greater than A. So what we do here is we compare the two boxes by measuring its length, breadth and height. So measurement is the comparison of physical quantity with its same kind, and the length, breadth, height, volume are called as the physical quantities. Next, I have three sentences. In all the three sentences, what is missing is the units. First is Ashok's weight is 81. What is missing here is the unit kg. Second, Ram is 20 centimeter taller than Akash. And in third, Aman studies for 3 hours. So hours is a unit. So whenever we measure any quantity, we write a numerical value followed by a unit. So units we can define as a definite amount of a physical quantity is taken as its standard unit. Next subtopic is physical quantities. All the quantities in terms of which laws of physics are described and whose measurement is necessary are called as physical quantities. The examples are length or a distance, time, mass, velocity, force and etc. all are physical quantities. Now if I want to describe the velocity, I have a formula distance upon time. So velocity is a law of physics, and to describe this I am using a distance and time, and distance and time is a physical quantity. Next, if I consider an example, acceleration is velocity upon time. So to define acceleration I am using a physical quantity, velocity and time. Next, if I want to find a force, the force formula is mass into acceleration. So force is a basic law of physics. To describe this, I am using a physical quantity, mass and acceleration. Physical quantities are of two types: fundamental quantities and derived quantities. Fundamental quantities are those quantities which are independent to each other. Derived quantities are those physical quantities which are derived from the fundamental quantities. The examples for the fundamental quantities are length, mass, time, temperature, and all these are not dependent on any other physical quantities. Whereas the derived quantities example are speed, velocity, force, momentum, power, etc. Now to define this, we are using the fundamental quantities. For example, speed is distance upon time. So to define speed, we are using the physical quantities. Next subtopic is system of units. It is a complete set of units consisting of both fundamental and derived units for all kinds of physical quantities. There are 4 kinds of system of units. First one is CGS. C stands for centimeter, G for gram, and S for second. Second one is MKS. M stands for meter, K stands for kilogram, and S stands for second. Third one is FPS. F is foot, P is pounds, and S is second. And the fourth one is SI system. S for system A and I for international. It consists of 7 fundamental units and 2 supplementary units. SI system of unit is widely used system of unit. Fundamental quantity, or it is called as base quantities, and its units. In total, there are 7 fundamental quantities. The first one is the length. Length may be width, height, depth, distance, displacement. The SI unit is meter and symbol is m. Next is mass. Unit is kilogram, symbol is kg. Next one is a time, seconds, S. Next one is the temperature. We write Kelvin, the symbol is capital K. Fifth one is electric current. SI unit is ampere, the symbol is capital A. Amount of substance, SI unit is mole and symbol is MOL. The seventh fundamental quantity is luminous intensity. The SI unit is candela and we write small c.